Hello team and welcome back to the channel. So in today's video we are going to get started with monitoring in DevOps. So this multi-tier application that we have been working continuously, we are going to perform monitoring for this today. Okay, so make sure to watch this video till end so that you don't miss out any of the steps. And here we have deployed the application with a custom domain and with SSL certificate available, right? So you can see certification is valid. So we want to monitor this. So what exactly will be the output of today's session? So we'll be able to monitor deployment, stateful sets of different namespace based. We'll be able to monitor all the worker nodes. We'll be able to monitor the namespaces with respect to the rates of byte received. Then based on pods, we can like networking, from networking point of view, we can monitor. Then we have performance monitor to basically monitor the node metrics of the worker node. You can see here. We can also monitor the specific pods for their node level metrics. All these things we can implement today, but again make sure to watch this completely so that you don't miss out any of the steps. Also team, for those who are preparing for interviews, you can check out batch 10 of DevSecOps and Cloud DevOps. Final price is 8169, which is I guess very cheap as per the syllabus, because we are having 40 plus projects and the content is around 120 plus hours. So make sure to check out. If interested, you can enroll. All the details will be in the description. Now with that being said, let's get started. So team, now our application is running fine. Next step would be to perform the monitoring, right? So before we jump into hands-on, let us understand about monitoring. Why do we need it and how it's very beneficial for us? Okay. So first question that we have is, what is monitoring? Correct? Now, monitoring is the process of collecting, analyzing, and visualizing data from our system, infrastructure, or even applications to ensure that everything is working as expected, right? So in that, we understood three very interesting points. First, what it does: collecting data, right? Second, that we understood is analyzing data, right? Third was visualizing data, right? So these are basically, in simple ways, these are the three steps that we use in order to perform monitoring on anything that we want, right? Why we need to make sure that we are performing monitoring is to we need to ensure that everything is working as expected. For example, like if I have deployed a website running on this URL, so we need to make sure that website is running, all the pods of this website are running. Like we need to ensure that. For that, monitoring is very useful, right? Now, when we talk about monitoring, we are not just checking if a server is on or off. We are also performing things like checking the node metrics like CPU, RAM, disk usage, those things. Then we are also going to be checking like number of requests that is coming to the website or application. Then what is the response time on the request is, right? Requests. Then we are also performing monitoring to check the error rates, right? What is the health of the application or website that we have deployed? Then if there are pod restarts, so we are going to monitor pod as well, right? Worker node also, if there are worker node failure, it will be a huge issue, so that also we need to monitor. And there could be some custom metrics that we want to monitor, so that also can be done, right? So basically, in short, monitoring gives us visibility, and without monitoring we are literally flying blind, right? Now, understanding how exactly this monitoring can be done, right? So monitoring, for performing monitoring, you'll be needing certain tools. Out of that, one of the most important tool and highly used tools is known as Prometheus. Okay. Now, what is Prometheus? First of all, it's an open source monitoring and alerting toolkit. Okay. In short, we can say that first of all, it's open source. Give me 1 second. It's open source. Secondly, it's pull based. See, Prometheus is a monitoring tool, but there are certain features from which we can understand how exactly it works. So I said pull based. That means if Prometheus want to monitor something, it needs to get the metrics, right? How does it get the metrics? By pulling it, right? From where it can pull. So let's say I want to monitor a website, 𝗕𝗏𝗄𝗏.com. So for Prometheus to directly work with 𝗕𝗏𝗄𝗏.com, what needs to be done, this website needs to have an endpoint like this. This endpoint, if this is present, then Prometheus can fetch it directly. So we need to understand very clearly that Prometheus can directly work with something like a website that we want to monitor if it is having a endpoint / metrics, right? From there Prometheus can pull it. Now thirdly, you should know about Prometheus that it's a time series monitoring system. What do I mean by time series? Time series means it's going to get the metrics on regular intervals of time. Okay. Now, when Prometheus has collected the metrics, it's going to store inside a special database that is known as time series database. Right. And as I told you, Prometheus is pull based like system, right? It's going to pull the metric from a specific endpoint. That endpoint will be / metrics. But you can understand very clearly that it is possible that there are not every website, not every application will be having this endpoint exposed by default. In that case, what is going to happen, right? In that case, Prometheus has something that is known as exporters. Now, what are exporters? So they are lightweight agents or services that can collect the metrics from a system and expose them on an HTTP endpoint for Prometheus compatible format. Okay. So for example, Prometheus needs, let's say we have a website 𝗕𝗵𝘃 and Prometheus need to get its metrics. But as I told you, Prometheus is pull based and works with a endpoint only. But by default, this website is not having that endpoint. So in that case, what we can do, we can set up exporters, which are lightweight agents or services. For example, one of the most used exporter is known as Node exporter. And from the name itself, you can understand it's going to focus on node level metrics. What are node level metrics? Those are CPU, RAM, disk usage. These are like node level metrics. So what node exporter is going to do, it's going to first of all, it's going to get installed. And then it's going to fetch all the metrics or basically expose all the metrics on a specific endpoint. Which endpoint? This endpoint, right? So once once all the metrics are exposed on this endpoint, then Prometheus can easily get them, right? So exporters are very useful when it comes to monitor some website or application that does not have a Prometheus compatible endpoint, so that Prometheus can work with it, right? So we could use exporters. Node exporter, one of the highly recommended exporter when you want to monitor the node level metrics. In addition to exporters, we have something else also that we should be knowing about. It's known as kube state metrics. So then we understood about node exporter, right? But when we talk about Kubernetes specific resources to monitor, that can be done using kube state metrics. Right. So what it's going to do, it's going to expose the Kubernetes related resources which can be utilized by Prometheus for monitoring. So what kind of resources it can expose? It could expose information about ports specific to namespaces, then worker nodes, then all the other Kubernetes related resources that we need to monitor, that will be exposed by kube state metrics very easily. Right. So all this data, all these metrics will be given to Prometheus for monitoring and analyzing, right? But the problem here that you'll be able to understand is that Prometheus is obviously it's going to monitor, but the data that it is having, it's not human readable. That means it's not present in such a format that we can understand it very easily and perform our own analysis. For that purpose, we have another tool that is known as Graphana. The main purpose of Graphana tool is basically to visualize all the data given by Prometheus and to present those data in such a very user-friendly format for us to perform our analysis, right? So basically, that's why Graphana is also known as a visualizing tool or visualization tool, you can say. Grafana is not performing monitoring. It's basically presenting the data, monitoring data by Prometheus to us in a very user-friendly format, right? Now we are going to set up all these things from scratch. One more thing you should understand. So basically, if I want to set up Prometheus, Grafana, all these things, what we have to do? Obviously we have to write our YAML file, YAML manifest file, and which will be kind of hectic also. So what should be like, what could be a better way which saves a lot of time for us? We could use Helm. Okay. One more thing before we jump to Helm, as I told you that Grafana is a visualizing tool that can present all the data in a very human-friendly format for us to understand. So for that, what we have to do inside Grafana, we have option to create dashboard. Okay. In dashboards, basically we provide information about key what we want to see. Like let's say I am providing information I want to monitor these number of pods in a specific namespace, and I want to see the result in a chart format or bar format, all those things. So that we can create inside dashboard. Again, if I want to monitor different things, I have to create multiple dashboards. But the problem here is that creating dashboard is not a very easy task. Even though it is a drag drop kind of thing, still it is kind of like little bit complex from my point of view, if I say. So you can understand if someone else created multiple dashboard for us to monitor everything, to see everything in a proper format, that will be really useful. And that's where Helm comes, right? So basically what happens inside, like using Helm, we can directly add a repo. What kind of repo I'm talking about? I'm not talking about a GitHub repo. I'm talking about a Helm repository. These repo will be containing kind of pre-configured code for setting up those monitoring tools, Prometheus, Grafana, those kind of things, right? Now, let us say that I have a pre-configured code that I can use. Now, if I want to set it up on my machine, obviously I have to change few things. For example, like I need to make sure we have load balancer URL so that we can access certain resources over like we can access certain resources over browser. I want to define how many replicas I want to have. Those kind of information is like custom thing for us, right? So let us say that I have a pre-configured configuration for installing these monitoring tools, and if I want to add my own configuration, these are like default configuration. So if I want to modify my like these thing as per my own configuration, I can create a separate YAML, small, very small YAML file. Inside that I can define my custom configuration. I want to expose load balancer, I want to make sure use storage class for volume creation, all those things we can define. And here we just have to create one YAML file, and you can understand that also this YAML file is not very big and it's very easy to understand also. So this whole thing makes very like setting up monitoring tools very much easier for us. Okay, and that's what I'm going to show you. So let us jump to hands-on part. First of all, these were the resources that we have created, right? We have 3 backend pods, 3 front-end pods, 1 MySQL stateful set pod, right? Now, what exactly we are going to do? So we are going to first install Helm on our machine. So I can go here, Helm, right? So let us install Helm directly using these 2 commands. You can install Helm. Installing Helm command is not a very complex thing. You can just get it anywhere. So let us see. Might take a little bit of time, I guess. Almost completed. Okay, so 99%. Always stops on that one. Okay, so Helm is installed now, right? Next thing what we have to do, we have to add the specific repo. We have to add the specific repo. We have to add a specific repo that for the installing monitoring tool. So I'm going to add the Helm repo by running this command, Helm repo. Right now, this has been added. Okay. Next step would be to just update it, and final step would be to write our own YAML file. Okay. So here we have this file. I'm going to create one directory. Let's call it as monitoring. Let us go inside it. Let us create our YAML manifest file. So let me first show you the YAML manifest file so that you can understand, right? Let me copy this and explain to you in a little bit proper way. Okay, so we have this YAML file. We are going to call this YAML file as the values.yaml, because for our like Kubernetes configuration, specific values that we want to have in our like deployments and pods, we are going to define here. First line, we have written alert manager enabled false. So like alert manager is another kind of exporter for Prometheus, which is basically responsible for sending alerts. Okay, if anything goes down, it's going to send alert, but for now we are not configuring it. Second, we have Prometheus, and then we define Prometheus specification. Okay, here we are defining that service type should be load balancer so that we can access the Prometheus over browser. Then we are saying storage specification, volume claim template, storage class name. Now whatever storage class you set up, you need to provide that, because as you know, storage class is going to be responsible for setting up the volumes. Then we define access mode, read write once, so that only one node can write to it, and how much storage we want, this much. Okay, Prometheus configuration, this is there. Then we have Grafana enabled true. That means yes, we want to use Grafana service. Again, it should be type of load balancer, and default username and password we are setting up to admin and admin123, right? Here then we are setting up node exporter. Again, for node exporter also I'm setting up load balancer so that we can access it over browser if required. And final thing that we have is kube state metrics. Okay, why we need to have kube state metrics? Because we want to monitor the Kubernetes specific resources as well, right? And here also type load balancer. Then we have additional srep config. So these are additional configuration where we define how Prometheus will understand key of like these exporters and kube state metrics, where exactly they are running. So first we have job name is node exporter target. This is where you provide the URL. Like first we are setting up node exporter configuration. Now since node exporter is also going to be deployed inside Kubernetes only, so we are providing name of the node exporter service. As you know, if you want to access any pod or application, you need to reach out to the service of that resource, correct? So here we are providing service name of that resource plus :9100, because this is where it will be running. This is the port. Same thing we are doing for kube state metrics also, reaching out to service name and then port 8080, right? Now this is the only configuration that you have to write, and for that reason only I was saying ki Helm setting up, using Helm you can set up monitoring tools very easily, right? So let us do that. Helm we have installed already, so let us create this file pi values.yaml. We can paste it here, save this. Just make sure that storage class name you are putting right based on what storage class you are using. So I have created storage class EBS-SC. If I show you again, kubectl get sc, you can see storage class I am using this one. Okay, so make sure you are choosing the correct name. Now once we have created YAML file, what should be the next step? Next step would be to deploy it. So generally we run command like this: helm install, then we provide the YAML file, the name of the release, those things. But here I'm going to be using a little bit different command, and I'll tell you the reason. If you can see what we are using, sorry, 1 second, let me show you in a proper way. Okay, so here you can see I'm using upgrade-install command. Why? Because this command, the helm install, it's suitable for the first time. But what if you want to upgrade or update changes in your Helm release? In that case, it's better to go with this command because this works for upgrading also, and this works for first time installation also. So use Helm upgrade install. Then we can define monitoring we can define monitoring. This will be the release name, this will be the repo, and this is the custom values file that we have created, and we are saying that it should be created inside specific namespace named monitoring. If it is not present, then create the namespace. So we are going to be using this command. So let us run this. I'll copy that and I can execute it directly here. You can see monitoring namespace was not monitoring is the release name, so it was not present, so it's going to install now, and it's going to create the namespace also with the name monitoring. So yeah, let's wait for this. So team, as we can see, it has been deployed, and we can verify it by running kubectl get all -n monitoring namespace. Right here we can see all the relevant tools are up and running. Most of them are already up and running. Some of them are still coming to ready state, right? But here one problem you'll be able to see, we can see for Grafana we have load balancer URL, but for Prometheus we don't have, right? So what should we be doing? We can run the patch command to convert this service type to load balancer. That we are going to do in a bit. First, let us wait for this to complete so that all the resources are up and running. Okay, I guess you can see all the pods are ready state. That's fine. Next up, what we can do, we can run this patch command to convert the service. So here, what things we are going to convert for Prometheus, for cube state metrics, and for node exporter. We can run this patch command, which is going to just edit the. See, this command is going to be something. Basically, we are editing the service type from cluster IP to load balancer. That you can do using kubectl edit _svc and then service name, and then you can modify. So I can run this command directly to patch it, and let us run. Okay, this is done, and now if I run the kubectl command, kubectl get _svc -n monitoring. Okay, you can see load balancer created. So now let us try to access these things over browser. So first let's go with Grafana. I can go over browser. I can put it here. Let's wait for this. It's running on port 80 only. I guess it might take a little bit of time to come into running state. So we will wait for it. Okay, let me remove the HTTPS. Okay, Grafana is running. As you remember, the default username and password that we gave it, what was that? It was admin and admin123, correct? So I can put it admin23. Let's confirm also, correct. Login, and you can see we are logged in. I can go to dashboard now. This is the most important part and very useful part. You can see here there are tons of dashboard that are already created for us to monitor. That means we don't have to put extra efforts to create dashboards. For example, I can click on this, and here you can monitor any specific pods you want. Okay, here what things, let me change it to last 5 minutes. So this data that you are seeing here, it's based on we are actually monitoring namespace. Let me change. Okay, so this namespace we are actually able to monitor network usage, current rate of bytes received, right, and all other things. But yeah, again there are many other things also to monitor. Let us go with that. First I'll go to pod section, select the prod, and here we have these many pods. Let me change it to 5 minutes. Okay, so whatever information is there with respect to pods, you can get it here. Again, I'm saying there are tons of dashboards. You can explore them one by one because each dashboard is going to show you different kind of things. For example, we have these compute resources. We can go to prod backend as 5 minutes. So for backend pod, you can see CPU usage and other data, whatever is available, you can get that information here. Okay. This is the most important part, because as I say, creating a dashboard, it's not a very easy task. You have to like understand a lot of things. But here, using this repo that I'm going to be providing, you can set up your own dashboard. You can use the pre-existing dashboard that can monitor almost everything. Okay, so you can go through it and you can explore a little bit more. And yeah,